Hi, my name is Connie Coclinas and you're watching the video on the Bagolini Filter Bar, also known as the Spicer Bar. Now, thus far you've learned about how to detect the presence or absence of suppression in ARC and how to map the suppression scotoma. What we can also do is measure the density of the suppression scotoma or the density of ARC. What do we mean by density? Density is telling us about how well entrenched that adaptation is. Let's say, as an example, you have a patient who's had a suppression scotoma from a very young age. It's been very stable, and we would expect that that suppression scotoma will be quite dense, very well established. On the other hand, you have a 7-year-old who's had suppression for a couple of months as they developed a new onset strabismus. Now, this patient's not going to have a well-established suppression scotoma because it hasn't been there for long enough and perhaps hasn't been even stable. So we're talking about how well established, how well entrenched that adaptation is, whether it be ARC or suppression. And inherent within that is how easily can I disrupt that adaptation? How easily can I anti-suppress a patient? And how easily can I destabilise the ARC? And the reason that this is important is because when we prescribe treatment to these patients, we want to avoid, in certain instances, destabilising or disrupting suppression and ARC. Now, ARC is actually a good thing to have. It gives you binocular single vision in the presence of strabismus. So we don't want to touch that. We don't want to disrupt ARC. Okay. With suppression, it has its advantages as well. Suppression is there to get rid of double vision. And if the patient has no potential or binocular vision, then if that patient's suppression is disrupted and they lose their suppression, they will have diplopia. And that diplopia will be what we call intractable. Intractable diplopia is double vision that we cannot get rid of. So the patient will forever experience it, and we can't give any treatment to that patient to get rid of the double vision unless we turn down to drastic measures such as occlusion of the eye or an occlusive contact lens, etc. So the patient will forever see that second image unless we resort to quite extreme measures of trying to have that patient not be able to see from the eye that's giving them the double image. Now, the risk of disrupting these adaptations becomes quite real as the individual becomes older. So when they reach the end of that critical period, so that's 7, 8, 9 and above, if you start treating patients in those age ranges, you need to be very mindful of the risk of disrupting their binocular functions if they've got ARC or disrupting their suppression. So you need to measure the density so that you have some confidence that you will not disrupt the adaptation, and you can monitor any changes to that sensory adaptation. Okay, so what is the Bagolini Filter Bar? It's essentially a filter bar that you see here, which has red filters of increasing density, and it has 17 red filters, and they become quite dark as you move down towards the bottom of that. And so, as I mentioned, it can be used for both conditions, suppression and ARC, and what you need to do is determine before you commence whether in free space, and what I mean in free space is that when you're looking with no devices in front of the eyes, so in free space, is the patient suppressing or do they have ARC? So that's your starting point. So if in free space, whilst looking at a target, the patient has ARC, then what you're measuring is the density of ARC. If in free space, when the patient is looking at the torch, they have a ARC, then what you're measuring is the density of the ARC. Now, to perform this test, what we do is we introduce the filter bar in front of the fixing eye. So in this particular example, the right eye would be the fixing eye, and the left eye would be the eye with suppression scotoma or with the ARC. And before we commence, we would shine a light in front of the patient. There would be a single torch because either it's being fused through ARC or because the patient is suppressing, in this example, from the left eye. Now, you don't need to put trial frames under the filter bar. In this example, there are trial frames on, but essentially you shine the torch, one light should be seen, and then you introduce the filter bar and you commence always with the very lightest filter. Okay? And what you're asking the patient is to communicate to you when the single light becomes two. And this is the point where you have disrupted the sensory adaptation. Now, if ARC or suppression is disrupted with a light filter, it means that the adaptation is not very well entrenched. It's not very dense. If, on the other hand, diplopia isn't seen until one of the very last filters or is not seen at any point through any of the 17 filters, then what you have is a dense adaptation. And so what that's also telling you is that patients who are disrupted earlier on with earlier filters, that you're running the risk of disrupting their adaptation if you treat them, versus you're not running the risk, a higher risk of disrupting them if they've got very dense suppression or well-entrenched ARC. The other thing is that, say for instance that diplopia occurs at one of these dense filters, on the next visit you can assess them again and see whether there's been any loss of density in terms of that suppression. So you can monitor what's happening with this adaptation whilst you're prescribing treatment that can disrupt their adaptation. Okay, one other thing to point out is that once you introduce the red filter, the light being seen will become red because you're putting it over the fixing eye, and because that eye is fixing on the target, the red filter will make that light look red. If your patient says to you that the light has changed to white, then what you have is a swap in fixation. And usually, again, this is an indication of a level of disruption, because what's happened is they've actually flipped over and preferred to fix with the eye that was suppressing originally or the eye that had the ARC. And lastly, in terms of recording, you indicate the test used, which is the Spicer bar, the distance that you performed it near, and we document the filter where the patient last had single vision. Okay, that brings us to the conclusion of this video. Thank you for watching.